Welcome to Star Chat, the cosmic journey that takes you to the farthest reaches of our universe and beyond. I'm your host, Carl, and I'm thrilled to have you join me on this fascinating adventure through space and time. Today, we're going to explore a remarkable discovery made by the James Webb Space Telescope, which has been unraveling the secrets of the early universe since its launch in 2022. Imagine a young star, about 16 million years old, nestled in the constellation Musca, approximately 310 light-years from Earth. This stellar newborn is surrounded by two massive gas giant planets, each with its own unique characteristics. The James Webb Space Telescope has directly imaged these planets, offering us a rare glimpse into the early stages of planetary formation. The innermost planet, about 14 times more massive than Jupiter, orbits the star at an astonishing distance of 160 times greater than Earth's orbit around the Sun. What's intriguing is that this planet is still surrounded by a disk of small-grained dust, indicating it may be in the early stages of formation or has recently experienced a collision. The Webb telescope has also detected water and carbon monoxide in its atmosphere. The outermost planet, about 6 times more massive than Jupiter, orbits the star at an even greater distance of 320 times the Earth-Sun distance. Its atmosphere is loaded with silicate clouds, which sets it apart from our solar system's gas giants. The Webb telescope has also detected methane, water, carbon monoxide, and carbon dioxide in its atmosphere. The puzzling combination of traits presented by these two planets raises fundamental questions about planet formation. According to astrophysicist Keelan Hoch, theoretically, the planets should be forming around the same time, as planet formation happens fairly quickly, within about 1 million years. The location where these planets formed and why one retains material around it, while the other has distinct silicate clouds, remain big mysteries. As we continue to explore the vast expanse of our universe, discoveries like this remind us of how much we still have to learn about the complex landscape of planet formation. The James Webb Space Telescope is revolutionizing our understanding of exoplanets and their atmospheres, challenging every atmospheric model we've used so far. We'll be right back with more fascinating space news on StarChat. Welcome back to StarChat. We're glad you're joining us again as we explore the wonders of the universe. Today, we're going to take a fascinating journey to the edge of space, where the Earth's atmosphere meets the vast expanse of the cosmos. Our story takes us to the magnetic equator, a region around our planet where the magnetic field lines run parallel to the surface. It's here that scientists have been puzzled by a phenomenon known as Sporadic-E layers. These layers are like particle traffic jams in the atmosphere, where ions and electrons cluster together, disrupting communication and navigation systems. But what's intriguing is that they can form near the equator, despite the fact that the magnetic field lines don't intersect with atmospheric layers in the same way they do at mid-latitudes. It's a mystery that has left scientists scratching their heads. To unravel this enigma, NASA's Aero Barjatia and his team have developed a mission called SEED, which uses sounding rockets to study these Sporadic-E layers from the inside. The rockets will release colorful vapor tracers, which will be tracked by ground-based cameras to measure wind patterns in 3 dimensions. Once inside the layer, the rocket will deploy miniature detectors to measure particle density and magnetic field strength. Imagine being part of a team that's on the cusp of discovering something new about our planet's interface with space. The data collected from these launches will help improve computer models of the ionosphere, which is crucial for understanding how Sporadic-E layers form and behave. It's a reminder that there's still so much to learn about our own planet and its place in the universe. As we continue to explore and push the boundaries of human knowledge, we're reminded of the awe-inspiring complexity of the cosmos. The Earth's magnetic field, the solar wind, and the atmosphere all interact in intricate ways, shaping the environment that surrounds us. It's a dance between particles and forces that's still not fully understood. So, what can we learn from this mission? By studying Sporadic-E layers, scientists hope to gain insights into the physics that governs our planet's interaction with space. This knowledge will help us better understand how to navigate and communicate in the vast expanse of space which is essential for future exploration and discovery. As we conclude this segment, we're left with a sense of wonder and curiosity about the mysteries that still await us in the universe. The pursuit of knowledge is a never-ending journey, and it's stories like these that remind us of the incredible work being done by scientists and engineers around the world. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, folks. As we wrap up another fascinating episode, I'd like to take a moment to talk about a development that's been making waves in the space industry. You might have heard that Blue Origin has delayed its New Glenn rocket launch once again, and this setback is more significant than it initially seems. As we gaze up at the stars, it's easy to get caught up in the excitement of space exploration and the innovations that are pushing us closer to becoming a multi-planetary species. However, the reality is that even the most ambitious projects can face setbacks and delays. In this case, Blue Origin's New Glenn rocket was initially scheduled to launch earlier this year, but now it's been pushed back to at least August, with some sources suggesting that September might be a more realistic timeline. This delay has significant implications for Amazon's Project Kuiper, which is a constellation of satellites designed to provide internet access to remote and underserved communities around the world. With SpaceX's Starlink already making waves in this area, the pressure is on Blue Origin to deliver its own solution. But as we've seen time and again, space technology is not for the faint of heart, and even the most well-funded projects can encounter unexpected challenges. As we consider the complexities of space exploration and the innovations that are driving us forward, it's essential to remember that setbacks like this are an inevitable part of the journey. The fact that Blue Origin is taking the time to address concerns raised by the Federal Aviation Administration and ensure that its rocket is safe and reliable is a testament to the company's commitment to excellence. So what does this mean for the future of space exploration? Well, it's clear that the competition between SpaceX and Blue Origin is heating up, with both companies vying for dominance in the satellite internet market. As we look to the stars and consider the possibilities that await us, it's exciting to think about the innovations that will emerge from this competition. As we close out today's episode of Star Chat, I want to leave you with a thought. Even as we face setbacks and delays, the pursuit of space exploration is a reminder that humanity is capable of achieving greatness when we work together towards a common goal. So let's keep looking up at those stars, folks, and remember that the universe is full of mysteries waiting to be unraveled. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.